Kia ora, I'm Troy, here as Chief Executive, and welcome to Stirring the Pot. Thanks for connecting. If you're new, here's what you can expect. We're going to be talking the tough stuff, the things that keep us middle minds up at night. There are many challenges facing our industry, and equally many opinions on how we should tackle them. Stirring the Pot provides a facilitated forum to discuss and challenge these viewpoints.
So let's get into the nuts and bolts of it. Today we're having a kōrero with our lead team from HERA, and we dive into AI research that HERA plans to do next year, where the industry is headed, sustainability initiatives and its uptake, and a whole lot more. So stay tuned. Also, fun fact, we lost some camera footage during the recording, but we were having such a good conversation that you may not see some of it. So looking back on 2025, what were some of the key inflection points for HERA and for the sector, that moments that actually signaled a genuine shift within the industry?
I can start with AI being probably something that has dramatically changed over the past year. So typically we think it takes about 4 years for a new concept to be widely understood by industry, but it's probably taken about only 12 months to have the developments that are occurring in AI more widely understood. So if we take the example that we proposed projects last year to the HERA board around AI, and there wasn't a really strong understanding around how dramatic the changes coming from AI were going to be, but 12 months later, the HERA board is, really supportive of AI projects, and that has really been phenomenal in terms of the industry's understanding of what AI is capable of, but also in terms of what AI actually is capable of. That's probably been the unprecedented technology uptake for our industry.
And what about from the fabrication side of things? Have you seen the industry shift a lot towards AI as well?
We have been working on AI projects for more than 2 years. We initiated a number of these projects under ACM CSC with our Australian partners at the University of Sydney, and also a number of smaller student projects with the AUT and University of Waikato to understand applications of AI. Technology is moving very fast, and so fast, and the time between you initiated the project, you have the concept of the project, and what is available within a year is mind-blowing. So it does shift your concept of time, what is possible, and the project timeline. Because what wasn't unthinkable 2 years ago, now it is common sense. Now everyone can do it. So we are at the point of what we call it exponential technology, and I think everyone, or most of the people, most of the fabricators are starting understanding it and embracing AI. AI is being embraced at the private level as a tool, as a helper, but the next step is to create agentic AI, so create a set of agents for this purpose to help with the workflow. This is a big thing, integrating of the workflow and integrating AI in business processes. A couple of challenges here is AI likes numbers. So if you have numbers, if you have digits, you have documents, that is for AI. Reviewing documents, this is for AI. We have a lot of data that is suitable for AI, also for training AI models. But the challenge is, if you don't have this data, if you have a system that is like a black box system, it doesn't generate data, so you cannot use this data for AI training. So this is probably the future focus area on how we can get this data from the manufacturing processes, from fabrication processes to train AI, and to make sense out of the whole production line, and including optimization, training of robots, and so on. It is an exciting time, and we have created also follow-up initiatives on AI in terms of what we're going to be doing and what resources we require. There's only one limitation, is our budget, because there are no limitations on the tasks we can undertake, or we can envisage to undertake.
Yeah.
As mentioned, AI is growing very quickly, and definitely would be the biggest change in the future. From engineering perspective, I believe engineering are using AI, but from structural engineering perspective, I think the most barrier is reliable data, because for any meaningful contribution, AI needs reliable data. So we need to ensure that, reliable data from real buildings will be produced to be able to use AI in structural engineering practice.
I mean, also, the industry has faced a kind of low construction market, and, from a systems perspectives, what do you think structural and behavioral barriers are kind of holding back innovation right now?
That's a tricky one. I think when the market drops, unfortunately, industry is focused on business as usual because they're having to survive, basically. And then the other problem is that then when things pick up, they're busily trying to thrive and respond to an increasing market. So I guess some of the things that play out would be the typical boom and bust cycles, which because of those extremes makes it really difficult for people to invest significantly in innovation. On the one hand, they don't know if they're going to survive the low times, and on the other hand, they don't know if they're going to be able to grow and respond to the good times. So yes, if there's kind of more evening out of projects over time, that would definitely facilitate investment in research and development and commercialization and innovation.
Another thing that I believe is a problem for innovation is about conservative design and construction process. That's a big problem. If designers, for example, are conservative, that will prevent them to be more innovative. Innovation needs to take risk, even if it is not a huge risk, but you need to explore a way to better do the things.
And since AI is accelerating across design, fabrication, and in your view, where does its true kind of engineering capabilities lie? Because as you were talking about how we all need data and we need a lot of it as well. So how long do you think it would actually take for AI to get to a stage where it can provide that engineering capability to the industry as well?
It is really difficult to predict because AI growing very quickly. So probably whatever we say today, a new development will change it completely. But I believe from engineering perspective, probably at the moment, the most important thing is using AI as a tool for increasing efficiencies. So at the moment, AI can play a significant role in doing jobs easier in a shorter time frame. So can play a significant role in efficiencies and saving time for engineers and designers.
There are quite a few aspects to what Kaveh said. AI makes integration of different tools potentially easier and using natural language. So communicating with tools like FEA models using natural language becomes a very easy task. And that will be the future of design. You tell design tool what you would like design tool to design, and hopefully you will get this outcome. It certainly applies some pressure on lower level jobs, on learners, to increase their skills, because the greatest value will be seen at the higher level knowledge, where high level niche expertise is available, and this expertise will be used not for the trivial task but for peer reviewing AI's work. So there will be pressure on younger professionals to upskill, I guess, to become experts, because non-expert or lower expert work will be undertaken by AI agents, as we all experience right now. AI will span between fabrication and also design. So designers will know better what is the best design for fabrication, what is the most cost-effective design, because this data will be available or instantly available in the models. So the concept of fragmented field of expertise, design and fabrication and maybe construction will not exist anymore because AI will eliminate all this fragmentation. So there will be a great scope for optimization, for better understanding, better designs, better design for robotics, better design for fabrication, and we have been working on some of this design for robotics for quite a while. One thing about AI doesn't change the physics. AI is to help us understand the physics. So fundamentals law of engineering will not change. So it means Hooke's law or whatever, it will stay in place. The only thing is what we're changing is the facilitating certain processes around it. And it's a great tool, and this is the future. And the future basically, maybe in the next half a year, is about creating agentic AI agents. So the AI agents can be easily integrated in the workflow, including design, fabrication, and everything in between.
I think that we are kidding ourselves if we don't believe that AI can already do the job of an engineer. Yeah. AI absolutely can. It's just that people are not taking the time to instruct the AI to do those things that it potentially can do. Yeah. Because engineering is perfect for AI because it's all mathematical equations. There's not a lot of creativity. It's black and white answers. Grey is something which requires more research, but we have to be conservative, and so it is always black and white. So AI is not that AI isn't capable, it's that we are not investing, as industry practitioners, we're not investing in adopting AI to the daily practices. There's no reason why, even if you look at students now, there's no reasons why students necessarily have to be educated in hand calculations. That's perfect for AI to do. Of course, they need to understand the engineering principles, but there is going to be dramatic disruption on what is the role of an engineer, what do they need to be trained on, and where do experts get developed. It's not going to be the best engineers are going to, the best practical engineers, the ones with the most knowledge, they're not necessarily going to be the ones that thrive. I think it's going to be the engineers who are able to think about the opportunities AI present, work with AI, kind of like a cobot, and then communicate with other practitioners to get them in the same thinking around this cobot idea of using AI plus humans.
And that's the thing, before we even get to that stage where AI completely influences our decision making, how do we really then safeguard and hold ourselves accountable? Because right now, in the present climate, AI can still make mistakes. And until we actually get to that point, whether it's next year, whether it's in 6 months, how do we kind of get to a stage where we can safeguard these judgment calls and have accountability as well?
I think there's an overemphasis on AI making mistakes, to be honest. AI makes mistakes in interpretation of words mostly, but in terms of calculations, once it knows a formula and you give it the data input to those formulas, it's not going to be making mistakes. So I think we need to really think about where the human value add is. It's not going to be in checking the calculations using formulas. Of course you would do that in the initial phases, but AI agents will be built that can be completely reliable. It's going to be around, well, how is that interpreted? What's the meaning of that to the project? How does that connect in with other disciplines, other aspects of the supply chain or the workflows? It's going to be really around connections, and it's not going to be too long that AI will be able to make those connections more quickly as well. At the moment, AI is perfect for routine calculations. What it's not good at is integrating disparate systems. But it's not that it doesn't have the capability to do that, it's that it doesn't have the access to do that. So once we can grant it access, the sky is really the limit. I personally don't think that there is anything AI can't do. It's just we have to invest the time to prescribe the guardrails for how it is thinking about what you're requesting it to do.
And see, HERA's kind of working on AI projects, working on sustainability projects, but do you see in the long run, given that there have been some questions about the sustainability of AI given its water usage, do you think that's something that would be included in when we're trying to calculate how much designs have been used for a building and how much AI has been used to kind of get sustainability credentials as well?
AI definitely has also a high electricity use. So I guess the ethics of AI usage is important. And maybe at some point when there's a critical allocation issue of where energy goes to, as a society, we probably have to look at what are the areas of focus for AI. Because, I personally use AI for everything in my life now. And even as a best friend, asking it for advice on relationship issues, But maybe when we're getting to the point where the whole world is using AI in that way, we need to allocate, maybe each person gets a just allocation of AI access. That means that we manage the environmental impacts. The other thing is that there's also a question that we've raised in our Nakopa Construction 4.0 project, which is if you improve so we have got a lot of focus on circular design, low carbon design, but by its very nature, Construction 4.0 is also significantly focused on productivity improvement, and that does mean that the sector will be able to produce more construction. And that obviously, if you look at the hierarchy, the top of that is, the first thing is no building is the most environmentally friendly thing. So there is a ethical conundrum there that we have to think about.
And now that we've been kind of speaking about low carbon design, and HERA has done so much in that space this year as well, do you kind of think we've moved beyond strategic intent to actually operational integration when it comes to industry? Have you seen members using this in practice as well? Have you seen that uptake?
Yeah, it is definitely. We provided lots of great tools, design guide and framework. For example, through our popular publication HERA R4164, we provided sustainable design guidance framework, which industry can usually implement strategies and solutions for lower carbon buildings and construction. Here I also would like to mention that our intention is to provide sustainable design solution, because when we talk about sustainability, we also target lower carbon, but focusing on carbon alone doesn't mean that you will deliver a more sustainable solution. Back to the other guides, we also published another detailed design guide, R4166, which basically we provided more detailed about low carbon and circular design process. We provided design examples, and through design examples, the engineers can see that how the solutions can be implemented for a real world problem and what is the benefit of them. We developed many digital tools, like, for example, fire protection optimization tool, updated slab panel method, web-based composite software. All our design tools will also help designers and engineers to deliver more optimized, which optimization has a strong and direct relationship with sustainable design and lower carbon design. So we provided practical solutions readily available to be used for real world problems.
I think what Kaveh is talking about is still siloed, right? So it's not integrated or holistic, which is what Construction 4.0 is promising. So the question was around how integrated are things, and I would say that no, they're still not integrated. So that's probably the challenge to overcome in a large part for Construction 4.0 is that we've got a lot of data. It's all disparate and it's all in different systems, and we need to integrate that and have interoperability between the systems. And so probably, where AI is being applied, it's in optimizing a single system or a single piece of software or a single design guide. But what we actually need is the design guide for low carbon being integrated with software to produce whatever, integrated with a workflow process. So it needs to be an integrated system, and that's what Construction 4.0 is all about. So hopefully with our extension for the 5th year of our research project, we will develop a pilot integrated system. And this is very complex research. It's all focused on complexity science, and that integration is actually very difficult to optimize across multiple criteria simultaneously at the design phase, which essentially is a holy grail. So we've got no illusions that we're going to solve the problem, but we will demonstrate how Construction 4.0 can be used to solve the problem. And I think with the evolution of AI, plus I think systems producers or even HERA, for example, we need to think differently around how do we use AI to start integrating. Because at the moment, all of the focus is on integrating a piece of proprietary software, but not on integrating that piece of proprietary software and how it works with another piece of proprietary software to optimize the overall construction process.
Because even translating all of this into something that's usable by industry, something that can be practiced, will probably take time as well, given that the Endeavour project has such a vast scope.
It does, and I think this is part of the business model issue, is that the owner of this proprietary software might be different to the owner of that proprietary software. So there's no incentive for investing in the integration. It's almost two competitors having to work together. But the system overall has to integrate to optimize and improve productivity for construction.
Yes, it is a limitation. The software integration is a limitation, and sometimes it is deliberately set in a way it cannot be integrated. And another challenge related to that software integration is integration of the robotic systems. Some of the robotic systems that can be purchased off the shelf, they're black box systems. So it is really difficult to get any data out of those systems, and the data is being sent to the manufacturers of the systems. And the manufacturer will learn, or manufacturer's AI will learn based on those black boxes. And the owner of the robotic system will not, or will rely on the supply of the system for this learning. So that's another challenge that we are facing.
Yep. And it's also a red flag for AI usage too, because essentially we're keeping AI ignorant of a whole lot of data and capability, because it's either proprietary or it's a black box or it's behind a paywall for peer-reviewed publications, for example. So there really needs to be an international system approach around how AI can have access to data. And I think over time what's going to happen is that the business models, for how software is created and even how it integrates with hardware are going to have to change, because the companies that are just steadfastly looking at their own siloed piece of software and how that integrates with a black box hardware component, it's not going to work in the long term. That will be uncompetitive, because what's going to really excel performance in the sector is the integration. And if it's not integratable, it probably isn't going to be widely adopted.
And in order to get these integrations and get access to all these data sets requires so much just trying to get everyone involved and getting information that's going to be harder, because it requires so much collaboration as well. So I'm kind of curious to see how that pans out over the next few years in order to gather that data.
The key value is in the availability of the data sets for training AI models. And whoever is the first right now will be the winner. And if the company, let's say, sells software and hardware, and for that purpose hardware, and the customer base is wide, they'll be able to get more data. More data is better product later on and more successful in terms of competition. So they will be winning. So there will be a lot of losers and only a handful of winners in this game, which is maybe a good for the industry, but in the long run we'll have probably face diminishing competition in the market, and maybe the prices will not fall as we wish for.
And that's always been the promise of Industry 4, is that data becomes the important commodity. And I think even in Kaveh's example, where you're getting data from real-world buildings rather than simulations or whatever, that means that data is going to be more reliable. So the quality of data becomes really important. But also I think there are many situations where synthetic data can be created so that, if you've got a particular problem, you can run it through a simulation and create data, and that data can be very reliable and used as equivalent data. So the business models are going to change too. And I think in an AI world where eventually everyone has the same capability of use of AI, what's going to be really important and what we think about a lot for HERA is the reliability of that data and the interpretation of that data. And that's where we see a really strong role for HERA, is that in a world where there's lots of unreliable data coming out from AI usage, you really want to know who it is that you can trust.
Yeah.
And in addition to what Troy said, we also are in a process of development of structural health monitoring 4.0 laboratory, TAPS 4.0, which will monitor real buildings, multi-story buildings, and that will create reliable, real-world building data.
And this is something the next question is something we had kind of discussed at the board meeting as well, is what, from your perspectives, what do you think it will take to actually embed research-driven standards and technology so deeply that they become business as usual for the industry, and kind of get to a stage where HERA research also has that influence on the industry as well?
HERA has been doing it for years, since day zero. And this is how we managed to grow that part of the industry, by research, developing guidelines, and influencing standards. We have been doing it all the way long, and we're just going to keep doing it. Probably the next level, having AI on our side, we definitely will be focusing on things that will accelerate our impact on the industry. We're going to be setting up AI lab at the Innovation Center. We're going to be training AI models for certain applications, for, let's call it, narrow AI, for specific, let's say, applications that can be immediately be productive and useful for the industry. That will definitely accelerate our research or the impact of our research.
I think we've changed our approach around design guides. So previously there was a focus on not creating a design guide until the standard had been updated or created. And that was really because of a liability issue, in that HERA is much more liable when we publish our own design guide than if we refer to a standard or even a peer-reviewed publication. But our industry really pushed for us to be preparing design guides before we even influence the standard. And so, over time you'll probably see that when we issue a standard, there's probably less uptake relative to if it's already in a standard and then we release the design guide. So it's kind of a artifact of that process.
Finally, when you look at 2026, we've spoken about AI, but do you see any other emerging technologies where you see, policy shifts or something that will redefine engineering practice?
From regulatory perspective, we had several standard development, and they definitely, most of them has been published, some just released for public comment, like composite standards. They definitely will change the practice. Lots of great solutions, innovative solutions, systems in new standards. From other aspects, like for example, digital initiatives, this year we started Digital Passport project, which currently our members have access to use it. So that is kind of implementing 4.0 in construction process. And that also can change the practice.
On the welding side, we're following a holistic approach to our industry. So we offer training, we offer certification, research, consulting, and all those ingredients, they inform each other and enhance each other. So on the training side, we try to offer courses based on standards, based on Australian and New Zealand standards, And recently we have published or basically facilitated the publication of the standard, which is welding inspector standard, AS2214 welding inspector standard. So we started offering courses in relation to the standard this year, first time. So it is a very popular course. We also initiated a new standard, which is called Certificate in Welding Engineering, so-called NZEC Welding Engineer. So the standard is work in progress, and hopefully we'll get the standard next year so we can start training new generation of, let's say, welding experts to this standard fairly soon. And this development sort of links our certification with the standards framework, and again links it to training and to technical expertise. It's kind of holistic, we call it holistic approach, or 4 pillars of what we're doing. This work is ongoing. There is no stop to it. AI will enhance it. AI enhances our training, enhances what we do. And the beauty of having AI on our side is we are sitting on years of data we can use for training AI models. Not everyone has it, and we have a good selection of data all across the industry we're going to be using for training our specialized narrow AI. So that's going to be our next step, also grounded in what we do anyway.
And you can hear from both Kaveh and Michail's responses how important our influencing of standards is in terms of driving change within the industry. I always think of the big picture, which is more at the moment, I think the potential disruption and push for change is going to come from political change. And so if the government does change at the next election, then you would expect that there's going to be a turn back to more focus on sustainability, Indigenous knowledge, and also a focus on broader outcomes for government procurement. And so I think, those are things that we need to start preparing the industry potentially for as well. Vocational education, there's been a lot of change within the system across successive governments, and that's created a lot of instability. So I think that when the pipeline does improve, there's going to be a potential problem around how the sector is going to be able to respond to an increasing demand. And I would anticipate that with an election coming up, there will probably be announcements about investments, and so that probably won't be too far away. So yes, that boom-bust cycle is really problematic and one that needs bilateral support to address.
So there you have it. Thanks for joining our conversation with the HERA Whānau today. This is the last episode for Season 7 before we break for Christmas. Can't believe this is the 129th episode that HERA has done. And we will be back with Season 8 next year, and there's a lot more to come. So hit and subscribe if you liked this video, and share it with people that you might think would find this interesting.